Today, we're diving into the story of two numbers that, believe it or not, literally built our world. They represent everything and nothing at all. This is the quest for zero and infinity. So let's kick things off with a question that honestly sounds more like a riddle. How did nothing end up changing everything? Well, the answer is kind of hidden in the history of math itself. Because that history, it isn't just about dry formulas and equations. It's really the epic story of two revolutionary ideas: zero and infinity. To really understand their power, we have to go back, way back, to a time before they even existed. Let's start in a world that was just trying to figure out how to count without a zero. You know, for thousands and thousands of years, math was just a practical tool. That's it. You can see it in stuff like the 20,000-year-old Ishango bone, with its simple tally marks. Just basic counting. You see it with the Babylonians and Egyptians who needed arithmetic for trade, for measuring farmland, and for building their incredible empires. Math wasn't abstract. It was all about solving real-world problems, right here and now. And those ancient roots, they run deep. I mean, the Babylonians used a base 60 system, which might sound totally random, but it's the very reason we still have 60 minutes in an hour and 360 degrees in a circle today. Yeah, their practical math is literally baked into how we measure our own lives. But then, something shifted. A big shift. In ancient Greece, the question changed from what works to why it works. Math was about to meet philosophy, and it was about to run headfirst into infinity. This was a monumental change, moving from just calculating things to actually proving them. Thinkers like Euclid, with his famous book Elements, introduced this idea of logical deduction. They'd start with these basic, self-evident truths, they called them axioms, and then use pure logic to build up these complex, proven theorems. All of a sudden, math wasn't just a tool anymore, it was becoming a true science. And well, this new way of thinking created some new, seriously mind-bending problems. The Greeks were really the first to truly wrestle with the concept of infinity. You had guys like Zeno posing these paradoxes that just tied everyone in knots. Like, to get anywhere, you have to cover an infinite number of smaller and smaller distances. So, how do you even start moving? For the Greeks, infinity wasn't a number. It was this philosophical monster that seemed to break reality itself. So, while the Greeks were wrestling with the infinite, a totally different revolution was happening on the other side of the world. And it all started by, quite literally, inventing nothing. And this part is just incredible. It's a really crucial distinction. See, other civilizations like the Maya, they used a symbol for zero, but only as a placeholder, to show an empty space, like in the number 204. But what Indian mathematicians like Brahmagupta did was a complete game changer. They treated shunya, the void, not as an absence, but as a real number. A number you could add, subtract, and multiply. A number with its own rules. This was the birth of zero as we know it. From India, this incredibly powerful idea started to journey west. It was picked up and embraced by brilliant scholars in the Islamic Golden Age like Al-Khwarizmi, who used it to develop algebra. In fact, our word algorithm comes from his name. This period was so key for preserving and building on this knowledge because later on, people like Fibonacci brought the whole system to Europe and it completely changed Western mathematics forever. Okay, so the arrival of zero in Europe totally sets the stage for the scientific revolution. And with it, finally, came the tools to tame that ancient Greek monster, infinity. This brings us to Isaac Newton and Gottfried Leibniz, who, working separately, came up with one of the most powerful tools ever invented: calculus. Calculus is the mathematics of motion and change. It's the language of a moving car, an orbiting planet, anything that isn't static. But to describe that kind of continuous change, they needed a way to handle infinitely small moments in time and space. And that's exactly what calculus did. It transformed infinity from that philosophical paradox that stopped motion into a practical tool that could precisely describe it. By working with the infinitely small, using this new idea called limits, mathematicians could suddenly do incredible things, like calculate rates of change or the areas under curves. They had finally tamed the infinite. And that brings us right up to today. These two ancient ideas, one born from the concept of nothing in India, the other a mind-bending puzzle for the Greeks, now form the invisible foundation of our entire modern world. I mean, just stop and think about it for a second.
The device you are watching this on right now runs on a language of zeros and ones. Modern physics, everything from Einstein's relativity to the weirdness of quantum mechanics, is built on this math. Our entire understanding of the cosmos, from the Big Bang to black holes, is described using the language of zero and infinity. It's everywhere.
And just when it seemed like the story was complete, a 19th century mathematician named George Cantor made an absolutely mind-blowing discovery. Some infinities are bigger than others. Yeah, you heard that right. He proved that even though there's an infinite number of whole numbers, 1, 2, 3, and so on, there is an even bigger infinity of numbers between just 0 and 1. This shocking idea created a whole new field of math called set theory. So, there you have it. Two simple ideas, one for nothing, one for everything, and they completely built our world. It kind of leaves you wondering, doesn't it? What's the next zero or infinity out there, just waiting to be discovered, ready to change everything all over again?